Over the years, the Nigerian Building and Road Research Institute has vigorously pursued one of its core mandates through a comprehensive and integrated approach in capacity building and investment promotion so as to foster the application of environment-friendly and energy-efficient innovation, construction materials, manufacturing technologies, and cost-effective building and road construction practices. The Institute, under the viable leadership of its current Director General and Chief Executive Officer, Professor Samson Juna, recently added new innovations to its research breakthroughs. They are the non-motorized roller compactor.
Non-motorized pedestrian roller. Non-motorized in the sense that it doesn't have an engine. It doesn't use fuel. It is designed to tackle climate change issues, situations where fossil fuels are burnt and emissions are produced. It came about based on a collaboration between Nigerian Building and Road Research Institute and IFAD-funded Climate Change Adaptation Support Program. Their focus is to design, construct, and fabricate operation and maintenance machines or equipment for rural roads and agri-related businesses. So this is designed to be pushed by a human being or animal traction. There is no fuel involved in it. It is made of the handle, that is the water tank containing water for wetting the laterite. Then the drums, it has two drums, one and the second one is there. Here there are openings where you can unbolt them and fill them with gravels. The reasons why we are using gravel is that because of the shape and size of gravel, as it moves inside the drum, it is going to create some vibration. So we have replaced the normal vibration that we have in a motorized roller with the gravels, and it also gives an added weight. This non-motorized roller can attain a weight of up to 1 ton. So if you need additional weight, you can add additional weight on it. So additional weight has been added to attain more stabilization of the subgrade soil. As you can see, the lumps are being delumped, and gradually, as it's being rolled upon, it will be stabilized.
The hammer crusher machine.
This particular machine. Basically, it is used to grind soft and medium hard objects like laterite, clay, kaolin, and some other things. So as you see this machine, you can use it in both built environment and construction generally. Purposely, this one was brought in because of the pozzolana to grind clay. You know, clay normally comes in lumps, but the same machine can be used to grind laterite. You see, we have observed that many of the people outside, when they want to do our interlocking block, they don't follow rules. You know, normally we have to see. This machine can now act as a dual purpose. Instead of pressing there to see, to just grind it. So you have your fine grain laterite already. So like I said earlier, it's a product of university. And then we have some modification in this, because we observe that in the one that is imported, the mesh, because we have a mesh inside through which the ground laterite or clay comes out. So at times it used to hook. Maybe the laterite is not very dry or whatever, it will hook inside. So we incorporate a vibrating mechanism under, so that just like manually you are sieving, as you start this machine, it will be vibrating at the same time. So everything that is ground will come down without delay, and that has a very good advantage on this motor, because like the old one, when the lateral of the material got stuck inside, the hammer that's used to grind it might stop. When it's stuck, it falls back on the motor can burn. But with this vibrating system, as soon as it is dropping, before you know it, everything that is being ground will come down at the same time. So, and like I said always, it's very, very cost effective because now we can do it in this country. The idea of freight and whatever is off. So, this is one of another new work from engineering material research department. I think we can demonstrate the machine for you just for some time. Try. You see, when this machine was started, you can see some little movement. Like I said earlier on, unlike the former machine, that is just the mesh is just static inside. This one, we do it in such a way that there's a vibrating system. So as soon as you start the machine, the vibrating system that the spring inside is jumping. That is why you see the machine still moving. So one of the modification we'll do again, this kind of machine, when it is finally installed, it has to be bolted to the ground. And you can see what is coming out like dust. Because already we changed the seal size. The one that comes from the former one has been to be big. But in this one, it's a very small thing. And because of that vibrating system that you are seeing, what is coming out is going to be very, very fine. I mean, the size of the grain that will come out will be fine and very, very small. And it can easily help mixing with other material. So like I said earlier on, it's another cost-effective machine fabricated fully from Engineering Material Research Department.
The road cutter compactor machine.
This machine you see here is a dual-purpose machine. It serves as a cutter and also as a compactor. It is basically used for road maintenance. Like we have many of our roads in Nigeria in a very bad shape. The main function of this machine is when you have a bad road that you want to repair. This is the cutter. This is one of the subsystems. Is a cutter. You use this one to cut the space you actually want to repair. You use it to cut the asphalt. After cutting the asphalt, you do the filling and you do your normal asphalt and whatever. Immediately you finish, under is have a compactor. This compactor has a vibrating mechanism incorporated, which you will use to compact the same space. So this machine can be used for those who are, instead of going for a different machine to do the cutting and another one to do the compacting, this singular machine can do the two works simultaneously. This machine is 100% fabricated in Engineering Material Research Department Central Workshop here, and it is diesel powered. You can see the diesel engine we use to power it currently, and it is very cost effective in the sense that importing this kind of machine, already one thing I want everyone to know is that this kind of machine is not even very popular. So it's more or less a new innovation in Nigeria entirely. So, and like I said earlier on, you have the cutting subsystem here. You can see the cutter, and under you have the tractor, which you can use to do the compacting after the area you want to repair has been finished. Another thing I want you to know is that in our bid to encourage technology in the country, this kind of machine is very, very useful to Nigerian road system, in the road sector, in the sense that if this machine is encouraged, many of our bad roads can be easily maintained without necessarily importing machine from abroad. Here is the hydraulic system that can use to either lift. If you want to drop this compactor, this is where it is dropped. So it will be pressed on this thing and the machine will be started and vibrate flight.
trials of Nigerian bitumen for road maintenance scheme, amongst others.
So this project is titled Field Trials of Nigerian Bitumen for Road Maintenance Scheme in Nigeria. It's a project that was initiated by Professor Samson Duna, the DG CEO, Nigerian Building and Research Institute in 2020. This project actually aimed at carrying out pothole patching across on some locations in Ondo State. The project actually began in 2019, where Nbrri had gone to Ondo State to collect some samples, which we tested to be able to get a mixed design ratio that we use in deploying the bitumen tar sand and the natural bitumen, which we sourced in Ondo State on Nigerian roads. So some potholes were selected in Odoshida in Ondo State. We got to the number of 108 potholes, which we intended to use our bitumen and our natural tar sand in patching all these potholes. So this is one of the samples we selected would be able to extract from Ondo. This is actually natural bitumen in its raw state. We got this and we were able to process it to be able to get our 6070, which we used as a binder for asphalt. So this equipment you see here is a locally fabricated equipment that we use for the processing of the natural bitumen. We were able to design by Nbrri on a small scale, and the purpose of this is just a research study. That's why we say that it's actually small, but Nbrri is working on developing a bigger scale equipment that we're able to use in processing bigger asphalt eventually. So this is the collection point. We have a valve that's set at the tip of the base of the processor. Inside the processor there is a filter that was fabricated to be able to sieve out samples that are put on top of it. So when it's heated, we're able to get the natural bitumen which comes in and is collected in this piece in here. So these are some of the tar sands that were collected. This tar sand is actually natural sand, it's normal sand, fine sand, but has been put together, has been binded together by the bitumen. So the bitumen that came out of the ground naturally, and natural sand. That's why it's called bitumen natural sand. So after hitting the bitumen, to be able to get it into finer particles, to be able to produce our asphalt, the bitumen comes out looking this way. It becomes finer, becomes a fine element. When you hold this material, you see that it has a binding. Normal sand that you collect is quite coarse in nature, but when with the bitumen contents that is actually found in the sand itself, you have a finer particle looking like this. So some of the equipment you see here, equipment that we use for the project itself. This is our compactor. We have a cutter. We have a compactor, a cutter, and some of our MC1s all in the truck that we use in conveying equipment to sites. So here is our MC1, which was sourced in Ondo State. We use this for priming of the roads after we had dug up our potholes and compacted it. We use this in priming it to be able to bind the tar sand and the soil itself. So here, before you actually carry out the patching of potholes, you have to cut the potholes into required sizes. So we have some of our staff here carrying out the cutting itself using the asphalt cutter. So most of the shapes we've got there are actually square-shaped potholes. So this is still the cutting process ongoing. And then after cutting out the potholes, you have to scrape out the unwanted elements, unsuitable material that are found there. So after, next slide please. This is a typical example of our potholes. And these are a cross-section of some of the potholes that we're able to actually cut. So here now due to finance and constraints in being able to mobilize material to site, we had to come up with a mini asphalt plant, that's what we call it. But it's majorly, we use tanks majorly to be able to heat so much material to be able to produce our asphalt on site. So here, these are some of the potholes that were cut, and we use our MC1 in priming it to be able to get the binding effect that we wanted between our tar sand and the soil itself. So this is after developing our mix ratio, where we have different sizes of aggregates mixed with our tar sand and our bitumen. We heated the samples to be able to come up with an asphalt now. Proper asphalt. So this is the production process, and this is the asphalt that we're able to produce on site. Same thing as something we're about to deploy it. But this sample here was heated to about between a temperature between 160 degrees to 180 degrees. So it's fine, it's very hot. So this is the asphalt after being deployed to the potholes, after placing. We had to rake it to be able to bring out the suitable sizes in terms of stones. And these are some of the samples from some of the potholes that have been patched using the tar sand. So after placing of the asphalt, we had to compact it to be able to get the maximum compacting effect. This is the compaction process still ongoing. Here we have some potholes that have been finished. So, other potholes have been finished as well. It is good to know that this project actually is the first of a kind being done in Nigeria. We have materials like bitumen and tar sands in huge deposits in the southwest in Nigeria. And Nigeria spends over 300 million every year on importing bitumen, and yet our road conditions are in a terrible state. It's good to know that the Institute has been able to carry out a successful road patching project, and we hope that going forward we'll be able to get funding that will enable us to carry out a successful bigger projects in the future. Professor Samson Duna, who is a lover of research, also instructed the team to make sure that we are able to train some indigenes of the area on how to use these materials and be able to patch their own potholes around their own location. So Nbrri did an outreach project with some of the communities to be able to train them and inform them on how they can extract some of the samples and use them on patching their own roads.
The granite dust from some of these quarry, you have them around. Not many quarry around us, but we have quarry around us. Communities around those places suffer serious, health problems. What should be done is that some of these things causing these health problems to them, to their facilities, to their residents, their structures, can be harnessed and brought back to the production chain. One of it is this granite dust, that we have used to produce this Nbrri interlock facing tile. We are responsible for everything from the beginning to the end. The production of the master mold was done by Nbrri. The mold was produced, plastic mold. The mold was produced. And that mold is, the plastic mold itself, is what we use to get this. This is the mold. So the whole idea is that what is considered as waste, what has been considered as waste in our society is being returned to produce a structural material, which is also, you can refer to as a concrete slab, because it is made of the cement, the sand, and the granite dust. In doing this, we have reduced the cost of some of these materials. One, you discover that the granite dust, replacing, part of the aggregates that is being used conventionally for production of this. In a way, we are trying to save cost. We are trying to cut cost. It is cost effective. Long term, ultimately, it is what? Cost effective. Why did I say so? We don't have so many quarries around. We don't have quarry all around us that we say, okay, we want to collect. So the cost of transportation, of getting this thing to where you want to even produce, except if you have to station it around the quarry and where you can get all some of this granite dust. The cost of transportation and some other little, costs add up. And by so doing, it seems sometimes when you produce concrete tiles like this, people want to argue. But based on what we have done, the cost analysis that have been done on this tile will cost just 60 naira. I mean, between 60 and 68 naira. 60 and 68 naira compared to the tile that you have there outside there. When you compare the cost, now you now begin to ask about the durability. The lifespan of this is what we are now talking about. The lifespan of this, it is very, very flexible the way it is. You use it for skirting outside. You can use it for skirting outside. Okay? With various designs, the walls outside. You can see we have put different colors. I mean, produce them in different colors using pigments. So this tile protects the wall. Okay? Then the load bearing capacity of this tile, okay, is better than that of the other type of tiles that you have that you want to use outside. That exterior wall tiles outside that people use for sketching. You see them all around. So that is Nbrri interlock facing tile for you. It is most effective. It is original to us. It is a means of converting waste to wealth. It is a means of adding beauty, okay, to our structures, because you can have them in different colors, different patterns. This is a particular pattern now, based on the mold that was produced by Nbrri. So you can have them in different shapes, depending on what you want. This is a particular shape that we have, produced. So that is Nbrri tile for you. I have said, I want to repeat again the advantage of this over others. It is very, very cost effective. We have done the cost analysis and we have seen it per square area, per square meter. And for just one, we have done it. And we see that it is cost effective, it is very, very durable, long-term durability. Okay, when you look at the time, over a number of years, then it's easy to maintain. You can maintain it easily. It can be cleaned.
With these technologies, the Institute invites viable investors, corporate organizations, and stakeholders in the road and build industries for possible partnership.